Alright guys, so
I'm sorry.
I thought you were doing it on purpose.
No, I'm sorry.
No, it's okay. So today we're going to be doing 2.2D, which is limits involving infinity, and vertical asymptotes without provided graphs. So we're going to have to figure this out without a graph given to us. So I'll explain some tips and tricks on how we can do that. So the main thing that you need to understand and learn about this is, first thing you always want to do is you want to factor whatever that equation is. Okay? You want to factor, first thing you always want to do, factor it. Once you factor it, then we can kind of do several things from there. Sometimes your numerator, your denominator, parts of it will cancel out, which means they're not actually vertical asymptotes, they're actually holes in the graph. Now, holes in the graph are important in algebra when we're graphing an equation, we're trying to be precise, but in this class, they're not so important because if we're taking in terms of limits, we don't really care about the holes. So just keep in mind they're not the same as vertical asymptotes. You do need to be able to differentiate between the two given an equation. With that being said, just make sure you're always looking for it after the factored version, has been found. Next thing is you are going to set your denominator that's left after canceling stuff out equal to 0. That's going to be your vertical asymptote. There may be 1 or 2, there could even be 3, whatever's left. Then you can also find your horizontal and oblique asymptote using the methods we learned about in the last few days. Oblique is when it's top heavy, horizontal is when it's bottom heavy or equal. Same methods as before, and that kind of gives you a guide for what your function is doing. And then lastly, your numerator, whatever's left, you can set that equal to 0 to find the zeros if possible. So let's go ahead and get into an example. So for number 1, is there anything I can factor in number 1? No. I mean, you could technically take out a 2, but when you factor out just a number, it's not really going to affect too much of your equation. So from there, what we're going to do is we're going to just go ahead and find our horizontal asymptote first. So the horizontal asymptote is based on top heavy, bottom heavy, or equal degree. What would you say this one is?
Bottom heavy.
Good. And we know that bottom heavy always have a horizontal asymptote of y equals 0. So we're going to go ahead and sketch that. Now we also know that to find a vertical asymptote, we're going to set our denominator equal to 0. And that's going to be this, which gives me x equals -2. It's going to look something like that. I'm sorry, it's -1. I don't know why I said -2. It's -1 and I graphed it at negative. So that graph is correct. Sorry about that. So as for your numerator, see how there's nothing I can set equal to 0 that will give me any value for x, so there's no point in trying to find one. This graph obviously doesn't have an x intercept because, the asymptote's there. So from here, what you're going to do to fill in your limit is your limit is going to be approaching the vertical asymptote, so you're going to fill in what your vertical asymptote is for those 3 limits. And now we're going to try to figure out what the limit is. So pretty much what you're going to notice is this new set of vertical horizontal asymptotes with a rational function usually acts as a new x and y axis. So it kind of bends around that axis. We just don't know where it's bending, so we have to figure out that information. So there's usually symmetry involved as well. The first thing you want to do is you want to plug in points that are really, really close to the left side and really, really close to the right side of the vertical asymptote. So the first value I'm going to start with, and this table will not be in chronological order, by the way. This is just more of like a scratch table for you to get your information you need. I'm going to start by plugging in a 0 into my function. So if you want to, you can write out the steps for plugging in 0, but you don't need to. Okay, I know you can do it in the calculator, and that's fine. So that's going to give me a 1/2 when I plug in 0. So I have a point at 0, 1/2. Now, that doesn't really tell me if my function is going to be going up or down. It kind of does with the horizontal asymptote, but I want to confirm it. So you want to plug in one value that's between that point and the vertical asymptote. So what's a value between -1 and 0? -1/2, right? Or -0.5. So you're going to plug in -1/2 to see what we get. So that's going to be 2 times -1/2 plus 2. That's going to be -1 plus 2, which is 1/1. So that's 1. So I'm here. Now you can kind of see what's happening. If you really want to be very specific about this and really want to verify that it's correct, you can plug in another point, like 0.75, negative 0.75, to get you closer. But you can start seeing what's happening here. So it's actually going up to what direction?
Infinity.
Good. So what we can say is on the right side of the vertical asymptote, which is part A of your limits, the function is approaching positive infinity. Does that tell us what the left side of the function is doing? No, we can't assume, so we have to go ahead and start plugging in points. So now you're going to do the same thing for the left side of your vertical asymptote. So the easiest point we could plug in is a negative 2, right? So we're going to plug in a negative 2. We get 1 over 2 times negative 2 plus 2. That gives me 1 over negative 4 plus 2, which is negative 1/2. So I also have a point at negative 1/2. 2, negative 1/2. So that's down here. And then what would be the next step to see what we're approaching for the vertical asymptote on the left? What should I plug in now? Good, negative 1.5, or 3 over 2. So I plug that in, and that's going to be 2 times negative 1.5 plus 2. That's 1 over negative 3 plus 2, which is 1 over negative 1, which is negative 1. So it's going to be somewhere about here. Oh wait, I'm putting in the wrong spot. It's right about here. So you can see that it's approaching what on this side?
Negative infinity.
Good. So does the total limit exist?
No.
Does not exist. So really, you want to pick 2 points on each side of the vertical asymptote to plug in to see what direction the function is going. Does that make sense?
Mm-hmm.
Okay. Next one. So in this case, is there anything we can factor in this one? Yeah, we can factor the numerator and denominator, right? What is that numerator going to factor into?
X, negative 4, 2.
You're close. Positive 4 and negative 2. And then what about the denominator? Difference of squares.
2 and 2.
Uh,
Plus 2 minus 2.
Good. Plus 2 minus 2. So will anything cancel out in this one?
Yeah.
The x minus 2's. So that creates a hole. That's where a hole is in the graph. We know we have a hole at x equals 2. Wherever the y is, we don't know. But it's not too important in this case. But we just know it's important that it's not a vertical asymptote. That's why we need to make sure we cancel it out. So our new equation is just x plus 4 over x plus 2. So is that top heavy, bottom heavy, or equal degree?
Equal.
Which means we divide the coefficients of the highest variable, which is 1 over 1, right?
Mm-hmm.
Okay. Now how do we find our vertical asymptote?
Denominator. Just for 0.
Yeah, we're going to set our denominator equal to 0, bless you, which gives you x equals negative 2. So we're going to plot at negative 2 on the x, and then also at 2. And then from here, we can put in the other side of our limit, which is negative 2, negative 2, negative 2. And now we're ready to see what else we can get from this. So, additionally, if you have a factor in the numerator, you can actually set that factor equal to 0. And that's actually a 0 of your graph. So that means we have a point at negative 4, 0. So that's a little bit of a trick you can use as well to get another point. Now from here, we just need to pick a value between negative 4 and negative 2 to plug in to get some information about where it's headed. So what's a good value we could pick?
Negative 3.
Good. Let's plug in a negative 3. Now keep in mind, you don't need to plug negative 3 into the whole thing, just the new version of that equation, the factored form. So I'm going to plug in negative 3 plus 4 over negative 3 plus 2, which is 1 over negative 1, which is negative 1. So you can tell that it's going down to negative infinity, right, as we get close to that vertical asymptote. And that's on the left side, so make sure you do it for B and not for A. And now we need to figure out what's going to happen on the A limit side, so we need to plug in some points over here. So what if we plug in 0 and negative 1? Will that tell us what's happening? Yes, so let's do 0 and negative 1. So if you plug in 0, that's going to give you 4 over 2, which is just 2. And if you plug in negative 1, that's going to be 3 over 1, which is 3. So I just kind of do it quickly in my head, but feel free to take your time plugging those in if you feel more comfortable with that. So I got those 2 points. So what does that tell me about my function? It's approaching positive infinity as I get closer and closer to that vertical asymptote. So does the total limit exist?
No.
Because they do not match. Alright. So number 3 is pretty redundant. It's the same kind of idea. So we're going to move on to 4. So for number 4, why do you think I want to do this problem as opposed to, like, why is it important we address this one? It's top heavy, good. So it has some kind of difference to it than the other ones. So how do we find, what kind of asymptotes do top heavy functions have? Starts with an O. Yeah, you're on the right track. Slanted or oblique, yep.
Oblique.
So oblique, we're going to find its oblique asymptote. We have to use synthetic division. You remember this? So to do the synthetic division, you're going to set up that little division bar. Your outside's going to be that value but opposite sign. And then the inside is going to be the coefficients of the numerator. So the coefficient of x squared is 1. The coefficient of x is 0 because it doesn't exist. And the constant is negative 3. So now you're going to do your synthetic division. Bring down the 1. Multiply. Combine. And multiply. That gives me 1, which we're going to reject because we don't care about the remainder. So what do these coefficients represent? Y equals what?
X minus 2.
Very good, x minus 2. That's my oblique asymptote, which is a linear function. So we can graph it just like we graph any linear function. First thing we want to do when we graph a linear function is plot the y-intercept, and then we're going to go rise over run the slope. So is everybody good with how I got that? Okay. So now, we need to find our vertical asymptote. So technically the numerator does factor. Not nice, but it does. It factors into this. Does everybody understand how I was able to do that? It's the difference of quote-unquote squares. So nothing's going to cancel out. So if we want to find our vertical asymptote, what do we need to do? How would we find that?
So this is 0.
Yeah.
Good number.
So we get x equals negative 2. Does everybody see where I got that from? Does anyone need any clarification on that? Okay, we get here. Alright, cool. So we technically do have 2 zeros, right? The zeros are root 3 and negative root 3, right? Okay. So root 3 is approximately 1.7. So we have a 0 at negative 1.7 and regular 1.7. Does everybody understand where I got that from? Anyone like, where's that 1.7? No? Okay. So if I took this numerator and set it equal to 0, I get x squared minus 3 is equal to 0. I get x squared equals 3. And then I take the square root of both sides, and I get x equals plus or minus the square root of 3. Those are my 2 zeros. If I put root 3 in the calculator, it's approximately 1.7, which means that technically I have a 0 at negative 1.7, which is like here, and positive 1.7. So that doesn't really tell me that much about where my function's going. It would be useful to have a value in the middle. What would be an easy value to plug in the middle of those two? 0. So that one you can probably do in your head. 0 squared minus 3 is negative 3. Negative 3 divided by 2 is negative 1.5, right? So we get here, and I can see what's going to happen now. It's going to have this U shape. Now you're going to notice with rational functions that they have this type of symmetry to them. It's not quite the kind of direct symmetry that you would see, but they're going to have some type of symmetry. So if it's here, it's also going to exist here in the same way. Now, if you don't believe me, you can plug in a negative 3. If you want to. You can plug in a negative 3, and you're going to end up getting negative 6 when you do that. And that's going to do the same thing. It's going to hug around those two asymptotes. So the main thing you always want to know is that your function will always be close, like just close to those asymptotes. The asymptotes kind of tell you where the function is going to be. All right. So what was our vertical asymptote again for the limits? Negative 2. We're going to see what's happening as we go towards them. So as we approach negative 2, on the right, what's happening?
Infinite.
Good, positive infinity. As we approach it on the left, we're going.
Negative infinite.
So does the limit exist?
No.
Good. All right, the last one's super easy. You guys can probably do that one on your own.